Okay, let's start. Welcome back. So, good afternoon. Thank you for the wonderful souls who wish me good afternoon. Appreciate it. So, the recording is running. Let's start with the positive point. As always, where is happiness? Is the question that we have been asking from last week. We'll continue with the same thing. Where do you look for happiness? So, uh, very a very rich man who's tried different things in order to be happy. Are you able to hear me? Somebody confirm that for me, please. Able to hear me, right? Yeah. Okay. Thanks. So, in order to be happy, he went on searching. He went travel many places, different countries, but still not happy. He chased everything, all kinds of addictions in the whole world, but his heart was devoid of happiness. So, someone told him that there was happiness in renunciation of life. You give up everything, your life becomes good. So he decided to try that too. He asked what to do. He said, like, there is one yogi there. You just go and he will show you the path of happiness. So he decided to try this. So he packed all his wealth, the treasure that he stored in his house, all the diamonds, precious stones, gold, all the expensive items, put it in a huge bag. And he took the bundle and he placed it at the feet of this yogi and said, Swamiji, I'm placing all this wealth at your feet. I don't need them anymore. I only want to seek peace. I want only to seek peace of mind. And I'm placing all of this wealth. Where is peace? Saying this, he fell at the feet of the yogi in total surrender. The yogi did not seem to pay heed to his words at all. He hurriedly opened up the bundle and checked the contents. It was full of dazzling diamonds, glittering gold. On viewing this, the yogi tied up the bundle and started running with it. The rich man somebody tells Shai to log in using Bits ID. In the very front of Shaili Shivaji Lankhe, tell her that she needs to log in only through Bits ID. Will automatically allow it. So he took the bundle and he ran away. The man was very shocked. He thought he surrendered to a cheat. So he said, what a blunder. His sadness turned into anger and he started running behind the yogi in a hot pursuit. Yogi was running, this guy was running. Big back and forth. The yogi was unable to run fast. Then He took the bylanes. Just give me one second. So he took the bundle, he ran through the bylanes, and he came to the place where he started, and he sat down. This guy came running behind him. He reached the place of the yogi, and he was panting for breath. And before this guy could say anything, yogi said, "Relax, here is your wealth, take it." You think I'm going to run away with that? The moment the rich man got back his wealth, he became very happy. The yogi said, "You see, all this wealth was with you even before you came here, but you did not derive your joy from them. It is the same wealth that is with you now, but you have found a great joy in your heart. So where did this happiness come from? Did it come from the wealth, or it came from within you?" Obviously, it came from within that particular gentleman. So, my dear friends, it is very clear from the story that joy and happiness are not outside us, they are within us. There's a very fantastic saying in the Bible which says, "The kingdom of heaven is within you." Just like the rich man, most of us are roaming around with a bundle of wealth. Many of us do not even realize the truth. Those bundle of wealth is our strengths, the good things that we have. This is the reason why we look up to others for our happiness. When your boss appreciates you, you feel very good. When the same boss tells you something you did wrong, you immediately feel stressed. So, the criticism should not kick you down. Remember that the kingdom of heaven is within you. Do not get lost in the trivial aspects of life. So every minute you're upset, please remember that you're losing 60 minutes of joy. What does an unhappy mind do? An unhappy mind often gives small things a big shadow. Don't miss seeing the bigger gifts of life, my dear friends. We have plenty of things, plenty of good things. Look for happiness within you and start enjoying your life. Excellent. Now we're getting back to business. Okay. Please confirm if my screen is visible. Yes. Okay.
Yes, sir. Screen is visible.
Thank you. Okay. Here we go. Started the recording. Told the students to be awake. Respond to me. So we're going to be talking about performance and tuning today. The performance and tuning, we're going to be talking about what are the preferred characteristics of performance, differences between performance and tuning process. So we'll be looking at how performance tuning is going to enhance an application or an infrastructure through the five major resource environments. We start with the server environment tuning, then we'll look at the disk storage environment, database, network, and desktop computer environment. Then we will learn how to assess infrastructure performance and the tuning process, then measuring and streamlining the performance of the tuning process. So while we're doing this, we'll also be talking about use cases. We'll also be talking about the types of questions that can be put across and how you should be in a position to answer this. So what is performance and tuning definition? Performance and tuning is a methodology of maximizing the throughput. One second. So it talks about the methodologies to maximize the throughput and minimize the response time for the batch jobs, online transactions, and internet activity. So the five different platforms of infrastructure, which are most impacted: servers, disk storage, databases, networks, and desktop computers. So the performance and tuning has two major activities. It normally has multiple sub-process owners, shares ownership across multiple departments. The process is highly iterative. The tasks have continuous and ongoing nature. The process tools vary widely among the resource environment. The process utilizes a large number of diversified metrics. One thing that we all need to understand regarding the performance is the performance and tuning is an ongoing process, highly iterative process. So if you're going to treat them as occasional tasks, eventually you will end up with only occasional good performance. Overall planning of the type and the volume of the current and the future workloads is very essential for a robust process for performance and tuning. So as we said, the major job of maximizing the throughput and enabling, we look into how we're going to handle these performance and tuning through the various server, disk storage, database. In general, when you talk about performance tuning, immediately people will say, throw hardware at it. Please remember, ladies and gentlemen, the quickest and the simplest solution that everybody gives to solve the problem of performance is throwing hardware, which is upgrading your processor and memory. It is not going to work. Performance tuning is a very highly iterative process. Overall planning of the type and the volume is essential to robust process. If I'm going to put in a table and compare the performance and tuning along with the other processes, what do I see? Performance tuning consists of two major activities. Other processes will have only one major activity. Multiple sub-process, overall one process. Across multiple departments, it's shared, single department. It has a continuous and ongoing nature. It's definitive start and end date. Highly iterative process, seldom iterative. Tools vary widely among the resource environments shared across departments. Process utilizes a large number of diversified metrics, small number of similar metrics. The five major resources, let's start with the servers. The major performance issue in a server environment is caused by the processor's main memory, cache memory, number and size of buffers, size of swap space, and the number and the type of channel. What are the common performance metrics that are collected when it comes to a server environment? So I need to look at the processor utilization percentages, how much frequently things are getting swapped in and out of the main memory, percentage of hits to main memory cache, the length and duration of the processing queues, the percentage of utilization of the channels, and the amount of the processor overheads. Length and duration of the processing queues. Amount of processor overhead used to measure the performance. So these are some of the servers, blade servers, rack mountable servers that we'll have to look at performance soon. And this gives you a picture of all the different slots. How does it look? When I talk about server environment, we are going to be talking about influencers for all of these. Database, the servers, everything. When it comes to the server environment, which influences my performance, CPU, server memory, cache memory, and the buffers. As you know, the central processing unit is your heart, and it interprets instructions and process data. So the number of CPUs and power determines the rate of work accomplished. One second, please. So the number of CPUs, you know, determines the power, the rate of work accomplished. So utilization should not exceed 70% at any time. Server memory allows for a server to read and write information being accessed from storage by the device. So the more memory available, the more items can be read, written, and performed. 70%. Cache memory is attached to RAM and is slightly slower than RAM. It stores instructions and data about the data is used, and the cache is expensive. The number and the size of buffers assigned for processing and can trade off the amount of memory available for processor-oriented transactions. So the buffers are high-speed registers that store data being staged for input or output. So you have computer memory hierarchy. So you know, as the pyramid goes up, it gets expensive, size gets smaller, right? And the volatility increases. So you have the tape, the hard disk, flash card, RAM, cache, and the registers. So if you buy a computer, you would note that they will say L1 cache, L2 cache. Cache is more expensive. So you have your memory, main memory. On top of the memory sitting your cache, L1, and then you register. So your processor will come to the register, see if it has the information. If not, swap the register with the cache. Not in L1, go to L2, not in L2, go to the main memory, not in the main memory, go to the virtual memory. If not, read the disk. So it's like you're trying to get some information. So if the information available in register, I can go back and execute. Otherwise, I have to go a step further away, slower I will get. So when I'm going to try to get something, but I don't have the space, I will have to use a swap. This is called as the virtual memory, which is set aside for temporary storing small and frequently used large parts of the program. So I'm not done with it. I'm doing something, you keep this, I'll go. It's like you bought vegetables, you have a bag full of vegetables. You're going to keep those vegetables with somebody and you're going to go and get back maybe something more and come back. So similarly, the process is not over, but you keep it here. Let me swap this and run the other process and then come back and take you and run you. So what kind of a data can store in there is the size of the swap, which can be adjusted to match the profiles of the application in the database. So the rate of processing the input-output operations is also determined by the number and the speed of channels connecting servers to external disk equipment. So channels are physical cables that connect the main memory to the external I/O devices, such as disk drives, tape drives, and printers. This is a typical example of swapping. So you swap in, swap out. So you have the CPU executing process A. In the swap space, process B is running. So process B will be swapped out and process A will come in and process A will execute. And then after this is done, process B execution, process A will be paged out and process B will be running. So you will hold there. This is called as a swap space. These are some of the I/O ports, the different ports that are really can be influencers because the different ports have different speeds. As you know, if you connect a USB 2 versus a USB 3, the speed at which the data transfers. Type A plug, type B plug, different plug to different plug, faster communication. So I want to do performance metrics. Start with the server environment. So what are all the performance metrics that I will have to look for? I will have to look for the processor utilization percentages, frequency of swapping in and out of the main memory, percentage of hits to main memory, the length and duration of processing the queues, the percentage of utilization of channels, the amount of processor overhead used to measure the performance. So I'm looking at a server monitoring tool. Anybody in your class working with any of these tools? Generally, students volunteer to give a demonstration. Anybody is doing that? Any performance monitoring related? No? Yes, no, something? Anybody has used any of these tools? Database monitoring tools, SolarWinds, Nagios for server monitoring, Zabbix. Anybody? So this is Nagios, where it shows the host status summary, the service status summary. So these are the top alert producers, list 24 hours. A CIO at a major defense contractor took an active interest in online response systems for his customers. And he wanted to know exactly when and why performance might be degrading. So it was tough sell for system analysts to explain to him why response time increased beyond service level whenever only a few users were signed on, yet seemed to improve with more users. So this was a major cause of concern. The cause of this performance paradox was that the main memory swap space, the way it was set up. So with many online users were signed on, almost all the available memory would be used for online transaction. So there was very little swapping out of the disk storage occurs. When only a few users were signed on, much of the memory was used by the batch job, and then the online users would frequently get swapped out, causing slower response times. So some of the performance metrics in a server environment for a true infrastructure company are crucial for maintaining uptime, ensuring efficiency, and detecting anomalies. So the server health metrics, the CPU usage, tracks the percentage of CPU utilization. High or constant spike can indicate a bottleneck. Measure the RAM in use versus available memory. Includes disk space, measures inbound, outbound data rates, enable servers are within the safe thermal limits, tracks hardware errors. Then comes application performance metrics. This is time taken by the server to respond to a request. Number of requests per second, application level errors, queue depth, number of server tasks waiting for resources, and database query performance. The resource utilization metrics, CPU steal time, especially which is relevant in virtualized environments, indicate how often the virtual machine waits for physical CPU access. Then we talk about the latency, disk write, cache hits, etc. Then we need to look at the user experience metrics, where you have the latency, uptime, downtime, concurrent connections. It's time for requesting the initiation. The security metrics we'll talk about: login attempts made, successful and failed login attempts, monitors blocked or suspicious traffic, intrusion detection, logs for unauthorized access, attempts or malicious activity. So then the operational metrics is about backup, patch, power usage. Then we have the infrastructure metrics. And then we have where we talk about the virtualization efficiency, cluster health. Then we'll talk about the incident and anomaly metrics. So the average time that it is taken to resolve an incident, mean time between failures, anomaly detection, logs. So these metrics should be collected and visualized in near real time using the tool. So I'll show you I'll share this link, which is the Nagios tool. It's a good read. So I've shared that. We can take a look at it. So these metrics should be collected and visualized in near real time. There are other tools, Prometheus, Grafana for visualization and alerting, ELK Stack, Nagios, and New Relic. This is a video. Let's watch this video. Be able to hear the sound.
Hello, my name is Vadim. I'm an IT specialist here from Nagios, and today we'll be showing you how you can monitor Windows with Nagios XI. Windows machines have a few services that we can monitor, such as hard drives, CPU usage, and RAM. By monitoring these components with Xi, you could take the first step towards seamless server monitoring and unlock the true potential of your Windows Server environment. With that being said, let's get started. To monitor a Windows device, we first go to Configure on the top, then click Configuration Wizards. Here, we could search, or we could click Windows and look for Windows Server. Once we found it, we click on it, and here it'll ask you to set up NCPA. This download link will take you to the latest version of NCPA. You will download the exe installer. We will want to go to the host machine and go find the download. We'll click yes, and then we'll click next. I agree. It will ask you to make a token. This token can be customized to anything you would like, and you will need to remember this token in the future if you would like to monitor this machine with multiple XIs. In our example, we are going to type XI for life and click next. Here we find NRDP, which is passive checks. We'll click next, install only just for this computer, install, and finished. Once we've installed NCPA on our Windows server, we can find its IP address, which in our case will be 103. The port will stay the same, 693. And now we enter in that token that we previously stated. We click next. We are brought to a page where we can select different metrics and parameters for warnings and criticals. Depending on the user, you could change the CPU and memory usage, as well as disk space, network traffic, server uptime, status, and event log monitoring. The defaults for the disk and memory space are a bit low. We recommend changing them to reflect your usage. CPU usage will monitor the overall system load of the CPU and see if there's any bottlenecks. User count will show you how many users are currently logged into the system. Memory metrics will show the main memory usage as well as the swap memory. Disk metrics, we could see that the C and D drive and its current usage. Network phase, so we could see that the Ethernet is at 10. We could change this to 100. All right. Network interface will show you if you have internet that's slower than usual. Services like Windows Defender and new ones can be added for another service check. Under process, you could add any more processes and the thresholds. Here are some Windows counters that can also be monitored. We'll leave this as default, and any plugins that we'd like to add. Then we click next. Under normal circumstances, it monitors every 5 minutes, and when there's a potential problem, it'll recheck it every 1 minute up to 5 times before sending a notification. We want to click next. When a problem is detected, it'll send a notification immediately. If the problem persists, it'll send a notification every 60 minutes. And this sends alert notifications to the contact and contact groups. Then we want to click next. Here we could add it to different host groups and service groups. And if we have any other parent hosts, we could add it here. Then we'll click next. And if we want to add more servers, we can save this as a template or just hit apply. This page shows that it's been successfully added. We can view the status details right here. With that, we see everything is okay, and we have one item that's critical. We can further view the performance graph, disable notifications for this service, or view the service by clicking on it. If you have any further questions or concerns, be sure to check out support.nagios.com. And if you've enjoyed this video, make sure to check out our YouTube channel for more helpful videos. Thanks for
Okay. So this link is shared with you. We'll share it towards the end we will share. It has the So we have done with the server. The next we are moving on to disk storage. The disk storage environment. The following list indicates the major performance issues in a disk storage environment. Cache memory, volume group, stripping, storage area networks, network attached storage, extends and fragments. We'll start with the RAID, redundant array of independent disks. We look at a couple of RAID options. RAID 0 means data stripping. What do I mean by data stripping is the same data is written across two blocks. So it writes faster. Data mirroring is redundancy. The same data is written in two disks. So this is about speed. This is about fault tolerance. If you come back and tell me I need both, then I'll tell you to go with RAID 1 plus 0, where the stripping is also happening and the mirroring is also happening. So block 1, block 2 is written. Block 1 is copied to block like this is also happening. So how do I improve the storage performance? I will use the cache memory in the RAID term. I will use a prefetch algorithm that will analyze the patterns of the fetch activity so that I can anticipate requests. Where like this is where like artificial intelligence is used a lot now. Volume groups are logical groups of physical drives that stay together. I can improve performance through seek and search times by combining frequently used groups of physical volumes into one logical group. I can do the stripping, which is a performance improvement technique in which long blocks of data that are to be read or written sequentially are stored across multiple drives, usually within a logical volume. Then we can also make use of the network storage. One is called as the SAN. Another one is called as a NAS. The SAN is a configuration enhancement that places a high-speed fiber optic switch between servers and disk arrays. The two primary advantages are speed and flexibility. So the network attached storage device is a server that is dedicated solely to the file share. Extends occur when the amount of data needing to be written exceeds the amount of original contiguous disk space allocated. Fragmentation result, which result in longer data access and slow response times. Then we'll have to relocate the files, compressing them to reduce the extents and get a good tuning method to improve the response. When I look at a particular SAN or a NAS device, what you can see here, you have several storage components put on a separate SAN backbone. So you have a client access LAN where all the clients access this LAN. They will get to an application server. They can get a different application server. All these application servers will come to this network, and then this data for all these servers can be stored across any of these storage devices. That is the beauty of SAN. NAS is about having a network attached storage, and then you're running a bus. which is your gigabit Ethernet network. Computers can connect, laptop can connect, anybody can connect. This is the difference between the SAN and NAS. So you have to pay attention to these types of areas where you will be looking at metrics, meaning influencers. We'll be talking about the database influencer. We spoke about the server influencer. Now we'll talk about the database influencer, storage influencer. All of those influencers, you can make a note because the question can be based on a case study where you will have to either use the influencer or the difference between two networks such as SAN and NAS to answer that question. So when you come to SAN, the SAN, you have a RAID system, you have secondary storage, you have servers, you have the switch. This is the Ethernet switch. And then you have those clients connecting into the switch. NAS is, you have these clients, you have a NAS storage, and then you have these servers connected. So a NAS is nothing but a single storage device that operates on data files. SAN is a local network of several devices. So when I look at the SAN implementation often uses Ethernet. NAS systems, on the other hand, uses fiber channel, and NAS device integrate private networks with several endpoints. So the main difference between the SAN and the NAS devices. That comes down to the selection of network. SAN systems transmit and move data over the network in the form of disk blocks, fixed size file chunks, making use of low standard storage net protocols that include SCSI, while NAS systems work on higher levels. To take a look at this, you have the virtual storage pool, and then you have the switches. So this is powered by this SAN Symphony. And then you have any storage linked, any client using any of this can connect to this and store. So this is your redundancy. So if you're looking for implementation timeline for a SAN, it's around 3 to 4 years, maybe 5 years. You plan, you select the vendor and the equipment, you implement and test, migrate data and integrate and training and so on. So you could get a question in your exam, which can be a case study, which says, okay, this is the situation. What will you do to suggest as an infrastructure manager? Would you go for a SAN and an NAS and give you a reason? So there can be a question there where you will have to look very closely to that question where there might be a small clue there, which will say any of these keywords. Local channel that connects fiber channel to connect several data devices. Transitioning from fiber channel to same IP. Many NAS devices now offer performance capacities, right? So this is a picture of a typical SAN device. This is your NAS device. Now I have this. One of these drives fail, you can just pop it out and put a real hard drive. It's faster. Let's take a look at the NAS versus SAN.
What is the difference between a NAS and a SAN? So that is the topic of this video. So we'll first talk about what a NAS is. Now NAS, or NAS, stands for Network Attached Storage. If you wanted to store data in a centralized location where it can be accessed from all of your devices on your network, you can do this by using a network attached storage device. A NAS is a storage device that is used for storing data, and it doesn't do anything else besides storing data. Now, typically a NAS is a box that'll have multiple hard drives in a RAID configuration for redundancy. And it'll also have a network interface card that'll directly attach to a switch or router so that the data can be accessed over a network. Then once it's on the network, it can be accessed from other devices, such as desktops, laptops, and servers, and it can be accessed as a shared drive. Now, NASs are typically used in homes, and they are also used in small to medium-sized businesses. But one of the main disadvantages with a NAS is that it has a single point of failure. So as an example, let's say if a component fails, such as if the power supply fails on the NAS, then all of the other devices will not be able to access its data. Now, a SAN, or Storage Area Network, is a special high-speed network that stores and provides access to large amounts of data. So basically, it's a dedicated network that's used for data storage. And this network consists of multiple disk arrays, switches, and servers. And because it has more than one of these devices, a SAN is fault tolerant, and the data is also shared among several disk arrays. So if a switch or a disk array or if a server goes down, the data can still be accessed. And when a server accesses the data on a SAN, it accesses the data as if it was a local hard drive, because that's how operating systems recognize a SAN. It's recognized as a local attached hard drive rather than a shared network drive like in a NAS. And SANs are also highly scalable because adding more storage space can easily be done without an interruption on the network. So as stated before, a SAN is a high-speed network, and that's because in a SAN, all the devices are interconnected, meaning that all of the devices are connected to each other, and they are interconnected using fiber channel, which is a standard for SANs. Fiber channel is fiber optics, and it has speeds between 2 gigabits per second all the way up to 128 gigabits per second. So fiber channel is extremely fast, and it's also very expensive. And most SANs today use fiber channel. But also as an alternative to fiber channel, some SANs use iSCSI instead, which is a cheaper alternative to fiber channel, but it's also not as fast as fiber channel. Now, one of the main reasons for using a SAN is because SANs are not affected by network traffic, such as bottlenecks that can happen in a local area network. And this is because SANs aren't really a part of a local area network. SANs are partitioned off. It's basically a network all by itself. And other reasons for SANs, as I mentioned before, SANs are highly scalable and they are also very redundant. And also, as you might have guessed, SANs are not cheap. They come at a very high cost, which is why they are mainly used by large companies and large organizations.
Super. Super. The links are shared. So this talks about the difference. You can read them through. I will run, I'll come back and give it to you. So here, the ratio of the server path to disk array is called fan-out ratio. One port of storage server is connected to how many servers? And that's basically the a simple comparison. SAN consists of high-speed subnetwork shared storage. Here, NAS is a server that is dedicated solely to file share. This is how the storage works. Okay, let me just. Okay. So basically, if you want to look at a typical fan out, so a fan out is, suppose you have a storage server with one fiber channel port connected to disk. That single port is connected to 4 different servers. In that case, fan out is 4:1, one port serving 4 servers. So where will we use this? Imagine a company running an Oracle real application cluster with 4 database servers. All these servers need to access the same shared storage link. Instead of dedicating one port per server, the storage administrator configures one port of the storage server to fan out to 4 servers. So what this does, this reduces the hardware cost and simplifies cabling, but it also means the bandwidth of that single port is shared among all the 4 servers. So what are the trade-offs? Advantages: lower cost, fewer cables, simpler setup. Disadvantage: potential bottleneck if all servers demand high I/O simultaneously. So what happens in practice? Fan-out ratio is a capacity planning metric. Low ratio, high performance, less contention. High ratio, cost efficient, but risk of performance degradation also. So this is the storage system. It's got the logic board, the actuator, the writer access, the platter. Can somebody confirm if the quiz is active? Thank you. So these are the different array RAID setups. Data is not duplicated, parity bits. You can go from RAID 0 to RAID 5 to RAID 10, how much space. So you talk about IOPS, read data, data transfer rate, etc. So redundant array of independent disks. So when you talk about the performance influences, so you have to see how is your cache memory performing, the volume groups, stripping, storage area network, NAS, extents, fragmentation. So you read this. This is a very interesting set of slides theoretically explained earlier. Now we are going point by point. So the prefetch algorithm is a set of software instructions that analyzes the patterns of disk storage, read request activity to anticipate preload or prefetch expected records of data. So look at this dashboard for the
Add a new panel, and I'm going to get the first one is going to be used disk space, and then the next panel that I add is going to be available disk space. So to get the used disk space, all we have to do is reference node file system, and then we'll get the available bytes from our job here.
selecting all the
Instance file. So I have to specify devices that I shouldn't be devices. So file system or the device that I don't want to track bytes from global bytes on the file system. So we'll subtract node file system available bytes, and we'll only specify the Jenkins job and the instance. And let's see what that returns. Okay, so now we have the available, I'll put this up here in the title, the available disk space. And in the y-axis, we have bytes. So this isn't very readable. So let's update the units to be bytes in the left axis. Okay, and now we get gigabytes in the left axis, so that's a lot more readable. And then under the legend, we have a lot of labels included in the legend, but the only labels that we want in the legend is device. So what I'm going to do is pull out the device from there and just have the legend include only the device name or the device label. Also, I said that this was available, but this isn't actually available. This is used space on disk. So let's go ahead and save this panel. So now we've got used disk space. I'm going to just drag it across here, so we have a little bit more space there, a little extra real estate. And the next query that we're going to add, or the next panel that we're going to add rather, is going to be available disk space. We're going to take bytes. We'll just add. And we also, this gives it, we only cleaner, and then in the y-axis. So let's go ahead and save and apply. So now our dashboard's looking pretty filled out. The last metric that we want to do is network traffic. So we want to see traffic, received traffic, and transmitted traffic. So byte order date. So we mentioned the order of bytes total. The instance is going to be. We want to specify the units and as our when we zoom in here, and go ahead and save our dashboard. So we added available disk space, and we added network traffic. And we'll go ahead and apply that. I'll kind of stretch this across a little bit. Great. And there we have it. That's pretty much the whole dashboard. These are some of the key metrics that you would want to track as a system administrator or someone who's responsible for maybe a cluster of servers or just a single virtual machine in this case. We can see the key metrics outlined in this dashboard. I hope you enjoyed this tutorial. And
so this is how you would track that in Grafana. Next, we are going to talk about how. Did somebody answer my question? Is the quiz visible? I asked that question. Can somebody reply? Thank you. So we're going to go with the database fine-tuning. The database fine-tuning can be server tuning, database tuning, maintenance, regular statistics, education training, all of this, PL, SQL, etc. So when I talk about the database environment, the physical layout of a database can greatly influence the eventual response times. 8 of the most common performance issues associated with the database environment are the placement of table files, initialization parameters, placement of data files, index and keys, locks, balance of system resources, access patterns, and database fragmentation. A table file which describes the various tables that reside within the database. Initialization parameters for database management software have a direct impact on performance. The placement of data files is crucial for minimizing access times and optimizing online response. The judicious use of indexes and keys that can drastically reduce the table lookup times. So you need to anticipate the read and write sequences to which parts of the database they will likely occur. Allow database administrators to map out the physical database in an optimal configuration. So over time, the data is no longer optimally placed for its optimized access patterns. So now the data gets fragmented, causing less efficient use of disk space. So you have the system OS, the SQL server, the query level, you have the activity monitors, database engines, and prior you will have data query execution. Once you have done that, you can also performance and tune in SQL. So you look for the fill factor, the proper length conversation, avoid select, etc. So what are the database environmental influences? So the placement of table This is a data dictionary. What database table is available here? So place in main memory or a cache. So revisit limits of the entire DB. You have the user or process limits, placement of data files, which is crucial for minimizing access time and optimizing online response. Index and keys. Keys are used to identify records. Indexes are list of keys within database to enable fast searching on particular record. Blocks balance system resources, access patterns, and database fragmentation. So there are tools, various tools that are available. We'll see one of the tools in action in a little while. SolarWinds is an excellent SQL database monitoring station where it can talk about all the resources, the SQL text, which are blocking on the different data loads. So let's see how the SolarWinds is going to work in action.
In this video, you will learn how SolarWinds Database Performance Analyzer, or DPA for short, can be easily deployed on Amazon Web Services to monitor both RDS and EC2 database servers. In addition, you will see how to identify and resolve database performance issues having the largest impact on your applications. To deploy DPA in the cloud, simply go to the Amazon Marketplace and search for SolarWinds. Click on Continue to deploy the AMI. Once deployed, all the additional configurations are completed through the web browser interface. The next step will be to register your database instances to be monitored by clicking on Register DB Instance for monitoring. In this case, we have already registered an instance. Let's look at DPA to find and isolate a performance problem. A customer has just called in and complained of slowness in their order entry application. To troubleshoot, first log into DPA and review the main dashboard. This will give us a high-level overview of what is happening in our environment. It's interesting that the order entry database, prod OE RDS, is showing several alarms. Let's take a closer look by drilling into that database. From the trend screen, first look to the Advice tab for any critical or warning statuses. The top two SQL statements, which are in the critical state, are especially interesting. For the first statement, the advisor is telling us that there are high amounts of blocking for the insert statement on January 20th. By drilling into that day in the trend screen, we can see a 24-hour view of the top 15 SQL statements. For our insert statement, we can quickly see that it has been running every hour with a huge spike beginning in the 9 a.m. hour. By drilling into that hour, we can view the blockers tab to see who is blocking this SQL statement. Here we can see that process ID of 83 has actually been blocking many other sessions for a long time. Each of these processes have spent over half an hour trying to run this insert statement. Look at the blocker details. We can quickly identify the user and see that they were performing an update to the same table. Now we can begin work on resolving this issue. Let's look at the tuning advice for a second SQL statement in Alarm. In this case, click on the More link to see all the details about the query and then review the execution plan. Notice that the advisor is suggesting several new indexes. At this point, we can decide to create and test them to see if they help improve performance. To maximize the value that DPA delivers, 24/7 monitoring is recommended. As DPA continues to monitor and collect data, the more comprehensive the analysis becomes, especially when identifying trends and anomalies over time. One surprise that many of our customers have learned is that it's not always the best idea or cost-effective to provision large database servers in the cloud. Instead, start with a small or medium-sized installation, use DPA to monitor performance, then add more resources when you need to. Test drive DPA today. Just visit solarwinds.com/DPA.
Excellent. Super. Super. Next. So the real life experience, an aerospace company instituted an extensive program to measure the online response of transaction in a critical engineering application. So the customers insisted that 90% of all transactions complete in less than a second. During the first few months, the service level objective was met, but even more improvements were sought. So a database consultant was brought in to suggest what are the ways to improve the performance. So what he told is, rather than entering several commands frequently, sequentially, he said you could chain them together internally to save on the keystrokes. So the response time would slightly exceed 1 second objective since multiple commands would be processed, but it took considerable marketing efforts to convince the engineers that rather than typing 10 commands and getting the response within 10 seconds, you would rather chain all those commands and put it in, and you will save on the keystrokes and you will get the response for all the 10 commands within 3 seconds. So that's basically was the improvement through the chain of commands. Just give me 1 second. I'll be back in a minute. Give me 1 minute. I'm back. So in the network environment, there are a variety of factors that affect the network bandwidth, the line speed, the protocols, the single sign-on, the number of retries, non-standard interfaces, broadcast storms. So the network workload simulators can be used to test the transactions, the response time under varying loads with different amounts of bandwidth. Line speed is another key parameter. Faster the speed, greater the performance. Network protocols give considerations to potential performance impacts, especially when running diagnostic programs such as traces and snippets. So single sign-ons, performance savings of logging on only once instead of multiple times for access to network. Transmission errors occur periodically on all network lines. The number of retries to be attempted will eventually impact the performance and should be monitored. Well, connecting the devices with non-standard interfaces can also cause major performance problems where it can end up locking up lines, introducing interferences, or extreme cases, flooding the network with non-stop transmission, which are called as broadcast storm. So same thing, it's given in a tabular format for your easy access. So the protocols, single sign-on, as you know, it's very, very useful because it's going to help you with signing into multiple systems just with one single sign-on. So it's going to reduce the overheads. Number of retries should be lesser. You should work on avoiding the non-stop transmission. So this is another network. These are all the network devices which influence on designing the data center bandwidth. So the port, the speed of the port, obviously the router. Then you have the firewall, where you will have the status LEDs, serial consoles, fixed power supplies. Then you have the switch. Then difference between an optical fiber and a copper cable. Then we have another network monitoring tool where you find out how things are performing in the network. The next thing that we need to obviously look at, probably the last one, is your desktop computer environment, performance influence. Automatic update for application. Configure centralized patch download through Windows Server Update Services and deploy from central admin. Automatic update for operating system. Configure centralized patch download through Windows Server Update Services and deploy the antivirus software, antivirus definition update daily through central servers, restriction software to protect children, anti-spam software, antivirus definition update daily through central servers, the personal firewall through group management policies. So we're looking at what are all the traits that is required for a process owner of performance tuning. He has to have a very high knowledge of the system software, components, network software and components, software configurations, hardware configurations. And they must be have the ability to think and act in a very tactical fashion. This is a real life experience. A CEO of a .com startup was very eager to show his staff how he could display their company's website in real time when he was having a staff meeting. Unfortunately for his IT performance team, he picked up the one day when new operating system release was installed improperly, and we slowed down the process and literally started to crawl. The technical support manager had some quick tap dancing. He was called in to the meeting to explain what happened. He was the guy who was actually set up the thing in the first place. So you will have to, you can use this performance assessment worksheet. Look at all those different categories. give them the ratings and find out the. So performance and tuning, we have a case study that's coming up. Performance and tuning is a methodology to maximize throughput. Performance and tuning has a significant difference when it compared with the other ITSM processes. As an ITSM manager, you need to understand the high influences that have a say on performance on server disk storage database. Appropriate measure of performance shall be designed based on the complexity and demands of the organization. So automation management tools shall be decided based on the needs. P&T process shall be continuously improved based on independent assessment. So look at a case study where on a web application, scaling and performance tuning. So the performance tuning in the infrastructure management focuses on optimizing system resources to ensure efficient operation and meet the performance expectations. So what it does, it involves adjusting the parameters, configurations or hardware components to achieve optimal speed, throughput, or latency. Here is a live example. So web application scaling, a global e-commerce platform is running a cloud infrastructure, started experiencing periodic traffic jams, spikes during sales events, which was leading to a very slow page loads and potential loss of customers. So the infrastructure team had to optimize the system to handle these spikes while maintaining high performance. So a large e-commerce website is running these databases. So what was the problem during Black Fridays? The website experienced 5 times increase in traffic, causing EC2 instances to slow down. The database queries took longer to execute. It was resulting in high latency, increased page load times. So what was the solution that was suggested? Was an auto-scaling EC2 instance set up, group to automatically scale the number of instances based on real-time demand. So this ensured that enough resources were available to handle the increased traffic. So we had to adjust the minimum and maximum number of instances, added proper indexes to reduce query execution time, reduce unnecessary reads and writes, and then the load balancing took care of the traffic. AWS elastic load balancing will increase the timeout and help connection intervals. And then we had a monitoring and benchmarking using AWS CloudWatch, auto scaling activation, database query tuning, and content delivery. What was the outcome? The website maintained high performance during peak traffic. Page load times were reduced from 5 seconds to 2 seconds. Auto scaling ensured EC2 resources were dynamically adjusted based on the real-time demand. Database response times did improve due to caching and query optimization. So what are the benefits? Improved user experience, scalability, cost efficiency, and reduced latency. So you can also practice these kinds of questions for your exams. Those are also attached here. So please do this kind of a case study that you can look at and refer to. Thank you very much. All the videos that we watched are attached here. We share in the PDF. Please be my guest. Take care. All the best. See you next week. Thank you.